Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 16th April 2023. The problem statement for today is unequal arrays. This problem is based on arrays and logical thinking. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says you are given two arrays A and B, each of length n. You can perform the following operation on array A 0 or more times. The operations are: select any two indices I and j such that one less than I and j and both should be less than n, and I should not be equal to j. Then set A of I, that is equal to A of I plus 2, and A of j is equal to A of j minus 2. Okay. Then we have to find the minimum number of operations required to make A equal to B. To make A and B equal, so that means to make array A equal to B. In note, it is given that two arrays are said to be equal if the frequency of each element is equal in both of them. And the next point is that arrays may contain duplicate elements. Okay, so the problem statement here says that we will be given with two arrays A and B, and we have to make both the arrays equal, and for making the equal we can perform certain number of operations on array A. That means we have to select two indices from I and j from array A, and we can increment the value of one element at a particular index by 2 and decrement the value at a particular index in array element by 2. Okay, so this we can do n number of times, and we have to find out in how many steps we can make A is equal to B. But if this is not possible, then we have to return -1. That means return the minimum number of moves to make A and B equal if possible, else return -1. So if this that means whatever we are trying to make both the arrays equal, if this is not possible, then what we do, we return -1. Okay, so I hope the problem statement is clear. So let's go and understand the given examples here. So the first example says the size is 3, n is equal to 3, and array A and B contains elements like 2, 5, 6 in array A, and B contains 1, 2 and 10. So here the output is 10. Output is 2. How the output is 2? First we select I is equal to 3 and j is equal to 2. Then A of 3 is this one, 6. To this we will add 2, it will become 8. And array of 2, this one, array of 2, we subtract 2. That means 5 minus 2, it will become 3. So this one, we are selecting I as 3 and j is equal to 2, this one. Then we add 2 to this and subtract 2 from this. So it will become 8 and 3. Next, this was one operation, that is one step, one move. In next move, we select I is equal to again 3, j is equal to 2. So to this one again we add this one 8 plus 2, that will become 10. We again are adding whatever the result we have got in the previous step, we are again adding 2 to it. So it will become 8 plus 2 is equal to 10. And in the previous step, whatever we had 3 there, so we again we subtract -2 from that. We subtract 2 from that, it will become 1. So that way we can see all the elements in array A have become as array B only. That means we are touching this 2 and in array A we are touching element 5 and 6. So 5 is made to 1 and 6 is made to 10. So 5 will become 1, this which is this in array B, and 6 will become 10, which is this in array B, and 2 and 2 are same, so we are not doing anything. Okay, so the main motive is that we have to make all the elements equal to B only. The frequency of occurrence of all the elements in A should be equal to B. So we are doing that in this operation. So this was example 1. If you move to example 2, so there it is said that array size is n is equal to 2 here. A contained element 3 and 3 and B contained 9 and 8. So here the output is -1 because it can be shown that A cannot be made equal to B. The reason is that here both the elements are odd here. So if you keep on adding two odd elements, it will always be an odd element. It can never reach 8. That's why we are returning -1 in this one, saying that this is not possible. Okay, so I hope both these examples are clear. So the problem requires the matching of elements of two arrays in a specific way to minimize the total number of moves required. The intuition behind the solution is to sort the arrays and partition the second array into odd and even numbers. Then match the elements of the two arrays in such a way that the difference between the two elements is minimized. The matching should be done in such a way that even elements in the first array are paired with even elements in the second array, and odd elements in the first array are paired with odd elements in the second array. If the matching cannot be done as I just described, then we should return -1. Finally, if the sum of the differences between the matched element is not 0, then in this case also the function should return -1. See, because ultimately whatever the number of steps which we are doing, it has to be equal. So the sum differences should be equal to 0. But if that is not equal to 0, then again in that case we return -1. In all other cases, we will keep track of the number of moves required to match the elements and return half of this number as the final result. Half of this number means in one step we are doing two operations, one to increment and one to decrement. That's why whatever we will get as the final moves count, we will divide it by 2. Okay, so with this approach I'll just show that how to solve the first example, where we took the example of this one: n is equal to 3, array is 2, 5, 6, and b is equal to 1, 2, and 10. So for that, let's move to this notepad here. So you can see I have taken that example only. N is equal to 2 and array and b is the same as example 1, where n is equal to 3, not 2, sorry. So here what we do, first we sort the element. So we sort both the arrays, first array in the ascending order and second array in descending order. So after sorting the first array in ascending order, it remains same because it is already sorted in ascending order. But array B will become 10, 2 and 1. Here, so we sort descending. Just writing it so that it is clear. Sort descending, okay. So here we can see, and then after that we will start matching. Yeah, but before that we will do one more operation. We'll divide B into two different arrays. One will contain all the odd elements, other will contain all the even elements of the B. So A will be again 2, 5, 6, and B will be again B even. It will contain 10 and 2, and B odd will contain 1. It will again maintain the same reverse order, whatever it was there in the sorted array. So from that only we'll just segregate even and odd into two different arrays. Then after that we start the comparison operation. So we will take each element from A and we'll compare with the respective element in B, depending on the parity of the element from A. So here we are checking the first element in A is 2. So since this is even, we will check with this this element with the even array of B. So we'll check with B even. And what we will check with? We will check with the last element of this last element present in this array B. So here we can see some differences between this 2 and this 2 is 0. So total number of moves is 0. So once that element is processed, we will remove that. So once we will remove that from array B. So once we remove that from array B, the B even will become 10 and B odd will still have 1 and B even will become 2. That means 2 is removed. B even will become 10, 2 is removed. In next step we will again now this comparison for 2 is done. Now we will move to 5. 5 is an odd number, so we compare this odd number with the B odd array. In B odd array we have only one element, so we compare with that. So we find the sum difference is -4 here. So the number of moves will be absolute value of this one, sum difference, that is 4 by 2. By 2, that will become 4 by 2 by 2 here. 4 by 2 by 2, that is equal to 2 here. Why we are doing by 2 here? Because for one operation, it is said in this problem statement that we are doing this operation, that we are incrementing by 2 and decrementing by 2. Okay. incrementing by 2. So that's why total number of moves will be half of that. Okay, so for moving from 1 to 5, moving from 1 to 5, it takes 4 steps, but in one step we can cover 2 steps. That's why altogether total 2 steps are required. For moving 1 to 5, 2 steps are required, because we can increment in each operation, we can increment the value by 2. That's why 2 steps are required. Okay, so even when this part is done, for 5 it is taken care. So now even 5 is removed, that means the corresponding element from the B odd element is removed. So this will be removed from B. That means operation for this element in B is already done. So now B odd will become blank. So now we will move ahead. So we have done operation for these two, and we have got total moves as 2 right now. So next time, next we move to 6. We saw that 6 is even. So now we will check, we will compare with this even B even array. So B even array contain 10 here, because 2 was already removed in the previous step. So B array contain 10 here. So now what will be the sum difference? Sum difference was -4 from the previous step. To this we will add the sum difference which we are getting in this step. So it will be like 10 minus 6, it will be 4. So -4 and -4, it will become 0. So in this step some difference is 4, and in the previous step we got some difference as -4. So overall it will become 0. That means till now whatever negative was done in the last time, positive we are doing this time. So that was some difference is 0. Okay, so that means the number of positives increased and number of negatives increased, both are same. Okay, so the total number of moves, so this was some difference, will become eventually 0. Total number of moves, in the previous step we had got total number of moves as 2. To this we add again the same like the previous time, absolute difference. So it is better to add here 0 also, so that it becomes, it remains consistent if someone sees this. Because earlier initially we will initialize num moves to 0, so that way initially it was 0, but in this step we got 2 here. So here when we are talking about this, so to the previous value of 2 we will again add the difference between these two. Here it will be actually 10 minus 6, whatever was there in the previous step, this one 10 minus 6 by 2. So again it will give 2 plus 4 by 2, that will again 2 by 2, that is equal to 4. So total 4 steps, 4 number of operations are required. So once this is done, then we will again remove the corresponding element from B even array. So even B even array will become blank. So B odd was blank in the previous step, B even became blank in this step. And after that we have to move to the next step. But here we can see we have come to the end of array A. So once all these things are done, then we check whether the sum difference is 0 or not. If sum difference, here we have got sum difference as 0. If sum difference is not 0, then we return -1. Again, because the same thing, the number of increments we are doing for a negative and for a positive, that should be equal. Okay, we have to count the number of moves, but the sum difference should be equal. So that's why it will justify that number of increments we did and number of decrements we did, that is equal. So sum difference is, if not equal to 0, then we return -1, else we return num moves, whatever we have got here, 4 by 2, that is equal to 4 by 2 equal to 2. So again we are dividing here by 2. See, so this division by 2 is that whatever the number of operations we are doing, so in one step it will cover both the things, incrementing by 2 and decrementing by 2. Both, all these are counted as one step only, or one operation only. So first divided by 2 was for increment the array value by 2. So how much, in how many steps that was done? That was done in one step. So that's why it was divided by 2. Because for moving from 1 to 5, it required 4 steps. Okay, actually the 4 skips was required, and in one step we could move 2 steps. That's why we divided by 2. And this division by 2 is for the negative one, because in one step we can increase by 2 and even as well as decrement by 2. That's why we are again dividing by 2. So we have got the final result as 2, which is again the same as here, which is in the given output here. So if you can see here, in the first, when we selected I is equal to 3 and j is equal to 2, so for a is equal to 3, it was incremented 2 steps here, and a is equal to 2, it was decremented 2 steps here. Okay, so if you check the total number of moves there, so so it will be again the similar way whatever we have decided here, whatever we have discussed here. So the total number of moves there, it will be divided by 2, and finally here whatever the number of operations which we are getting here, we again divided by 2, because here it will cover both part, one for this part positive and for the negative part, that means addition part and subtraction part. Okay, so I hope this example is clear, and what all steps are involved in this, it is pretty clear to you. So with this approach only, whatever we have discussed, the algorithm which I have shown in this example, with this only I'll try solving this problem. So I have already prepared a solution for that. Let me just copy it here. It is exactly the same whatever I have explained there. Here I have given the comments as well, so that it becomes easy to understand the solution. So let's come from the beginning, that what all things are being done here. So what we are doing, first we are sorting A and B in non-descending order, that means in ascending order. Then we do a reverse of B, so that it becomes a sorting array in descending order. Okay, the way it was done in this example where we saw this one, sorry, not this one as well, yeah, this one, sorry, here we sorted A in ascending order and B in descending order. So we sorted initially both by in ascending order, and we reversed B. Okay, so B became in descending order. So the motive is that sorting A in ascending order, B in descending order. So that we did. Then we have initialized variables like number of moves and sum of differences. Both are initialized to 0. Now we are creating two array list to partition array B into odd and even array list. Okay, so that is odd nums and even nums. Then we do we have a one for loop here to partition all the elements in B to odd and even numbers. So we are iterating over n, and we are checking if B elements is even or odd. If it is even, then we add to the even nums. If it is odd, then we add to odd nums. Okay, so after this step, B will be partitioned into two steps. It will be like this one, B even and B odd, something like that. It will contain two elements like even and odds. So it will contain two different arrays. So after that, we will start with the operation of matching. So here we will iterate through that means we have for loop here again, and we iterate over all the elements in A, and we check if the array element is even or odd. If the array element is even, then we initially first check if there are any elements left in array B, even elements left in array B. So if even nums is equal to 0, then we return -1 here. Okay, so here if at any point this B even, B odd, this becomes minus, and we get an element, if that means if B odd becomes blank, and we get some element in A which is odd, in that case we cannot do any comparison, so we'll simply return -1. So that only case is handled here, that if the A element is even, but in even nums we get that that there are no elements left, so we return -1. But if this is not the case, then what we do, we calculate some differences between the element of B and corresponding element of A. So for that we get, if it is right now we are checking the condition of even, so we get even nums dot get, we are getting the size -1, that means the last element from this even num array, that means B even array, and we are subtracting A of I. This is exactly the same operation which is this one, sum difference and add num moves. Okay, so whatever the sum differences which we are getting, we are adding to the sum differences from the previous step. Initially it was initialized to 0, so it will still be 0 in for the first case. Okay, whatever we have taken the example, and after that what we do, we add the absolute difference divided by 2 to the number of moves required. So number of moves required which we have got in the previous step, to this we add again the absolute difference between how many numbers of steps taken, That means the number, the total number of moves required. We are again dividing this by 2 because in one move we can skip 2 points. That means in one step we can get 2 moves. That's why we are dividing it by 2. So whatever the value we get, we add it to num moves. Then after this task is done, then what we do, we remove that element from array B. Okay, so right now it was taking, we are talking about an even element. So we are removing that particular element from even nums. Even nums, what is that? Even nums. Even nums is that the array from B which was containing all the even elements. So we are removing that particular element from B. From even nums, that is again the array of B only. Okay, so this was the case when it is even. Similar case will be there when it is odd. That means if this condition is not true, a of I modulus 2 is equal to 0, this is not true, then we have to check this for odd. So here also we will again check the same thing. If the element in A is odd, then check if there are any odd elements left in array B. If not, then there is no way to make sum of corresponding elements even. Okay, so for that one we can directly return -1 here. If this is not the case, then again we will do the same thing whatever we did in the previous step. Only difference is that now we will, instead of referring to even nums, we are referring to odd nums, because this time we are dealing with the even number element, odd number element from array A. Again we are calculating the sum difference. Whatever sum difference we are getting, we are adding it to the previous value of sum difference, that is sum difference plus or equal to. Okay, similarly we will calculate the number of moves. So whatever the number of moves which we have got in previous step, whether it is odd or even, to this we will add the number of moves which are getting in this step. Again it is divided by 2, again with the same reason. For one negative moves, that means for one odd moves, that means one step requires 2 moves. So for the number of moves, we can divide it by 2. And again we are again removing it from odd nums array once that array element is once that element is processed. Okay, so this will be the complete for loop here. After this we are checking if some difference is not equal to 0, the way we did here, this one. If some difference is not equal to 0, then we return -1. That is, there is no way to make the sum of the corresponding elements even. Okay, so now the thing is that return, now after this, if it is not equal to 0, then return -1, else we return the total number of the minimum number of moves required to make the sum of the elements of A and B even. So for that we divide the number operation by 2, because in one operation we are doing both addition and subtraction. So we are dividing it to 2 so that we get the total minimum number of moves required to make all the elements equal. All the elements equal, that is between A and B. So okay, so this was the complete solution. And here we have one helper method here, that is called reverse, for reversing the sorted element B into descending order. So for that we are using this reverse method here. So what we are doing, we are looping through the array from the start to the middle elements and swap the elements at the current index with the corresponding element at the end of the array. So we are only iterating to the halfway, and we are just swapping the elements between the starting of the element of the array and the end of the array. So this way we will get the sorted array there. Okay, so this was the complete solution for this problem. Let's try compiling this code. So here you can see we have got correct output for this given example here. This is the same example which we have taken example as well. This was there in given example as well, and this is there as a first test case. So we have got correct output for this. Let's try submitting the solution. So here we can see it has covered all the test cases. So this problem has been solved successfully. So talking about the time complexity of the solution, it is in the order of n log n, where n is the length of input arrays A and B. The initial sorting of arrays A and B takes big O of n log n time. Okay, and the reversal of the array B takes big O of n time. The partitioning of array B into even and odd numbers take big O of n time, as does the subsequent loop that matches elements in A and B. So even that matching of element, that also takes big O of n time. Therefore the overall time complexity is big O of n log n. And when we are talking about the sorting takes big O of n log n, because whenever we use arrays.sort, it internally uses merge sort for sorting the element. That's why we are getting the time complexity for this is n log n. Okay, so this was the complete solution in Java. So let's move to the C++ editor. I have even prepared the solution for C++ language as well. Here the logic will again be completely same. Only the syntactical difference we get between C++ and Java, that only is here. See here again the same thing. We are sorting A and B in reverse order. Then we are dividing B into two different arrays, that is even and odd arrays. Then we start the matching operation. For even elements in A, we are matching with the corresponding even array of B, and we count the number of moves, and once that operation is done, we remove that particular element from B. Similarly happens for odd elements, and once all these operations are done, we check whether the sum difference is not equal to 0, then we return -1, else we return num moves by 2. The completely same logic, only it is in C++, the previous one was in Java. So let me try compile this code. So even in C++ we have got correct output. Let's try submitting the solution. So even with C++ we have got correct solution. That means it in C++ also it has covered all the test cases. Okay, so I'll provide the link for this question and the link for the solution code in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.